Hello and welcome to another video from Cortigo. Today I'm going to be showing you a deep dive into our configuration software, TigoEngine. This video is meant for intermediate users who want to learn more about each of the settings available to each wireless port. Today, we will be using the following architecture. First, I will add a new wireless device to the Tigo master that I already have in TigoEngine. To do this, I will open TigoEngine. Then I will click on my desired wireless master, and inside the port configuration tab, I will click the plus button, then scan for new devices. I will select a device, but before I select pair, I click on advanced. In the advanced tab, there are several options. I will explain each one of them in detail. The port number is the wireless connection number. It determines the location of the process data inside your PLC or IIoT architecture. Port mode determines how the wireless connection behaves. Inactive means the wireless port is disabled. Cyclic auto will configure the wireless port and pair the wireless device in the same action. Roaming auto is a feature that is still under development. Soon, it will allow for quick disconnection and reconnection of a wireless device to different masters. Cyclic will configure the wireless port but not pair the wireless device at this time. Roaming will configure the port the same as roaming auto, but it will not pair the device to the port at the time of configuration. Validation and backup refer to how the wireless IO-Link device interacts with the wired IO-Link device. Validation checks if the vendor and device ID of the wired IO-Link device matches what the wireless device is told to expect. Restore is when the wireless device uses stored settings to program the wired IO-Link device. Lastly, backup refers to whether the wireless device stores the configuration of the wired device now or later. TigoBridge can interface to iLink I/O, digital inputs, or digital outputs. Therefore, the bridge mode can be iLink, digital input, or digital output mode. Additionally, if you require count data, please consider our Tigo counter. Port cycle time is normally calculated based on the settings of the wireless connection and the amount of data on the wired sensor or actuator. However, if I desire to manually configure the response time of the wireless connection, I can use the port cycle time settings to set the cycle time to slower than the natural response time set by the wireless connection settings. Track number refers to the antenna to which the device is connected. Our Tigo Master 2TH can connect up to 16 devices using its 3 antennas, and our Tigo Gateway can connect 8 devices to its 1 antenna. Slot number refers to the position of the wireless connection on the track. Device TX power defines the device transmission power level. Reducing this number will shorten the wireless range. In some cases, this is preferable to allow more devices to coexist in certain areas. Max retries sets the number of subcycles inside each wireless cycle. Increasing this number increases the robustness of the wireless connectivity, but increases the wireless cycle time as well. For example, a max retry of 5 means that there are a total of 6 subcycles inside the wireless cycle, meaning it will take 10 milliseconds to complete one wireless cycle. I am alive time serves as the watchdog timer for the master device connection. It is calculated by multiplying the base time by the multiplier. The wireless master uses the I am alive time to determine when a wireless connection is lost. Slot type refers to the number of slots the wireless connection occupies. A wireless connection can be single slot, which occupies 1 slot on a track and transmits 1 byte of input data per cycle, or double slot, which occupies 2 slots on the track and transmits 14 bytes of input process data per wireless cycle. Max PD segling refers to the number of bytes of process data output transmitted on each wireless cycle. Configured vendor ID is used if validation is enabled. When validation is enabled, the vendor ID of the wired IO-Link device needs to match the configured vendor ID. If validation is not used, then this value is not considered. Similarly, the configured device ID refers to the wired iLink device's expected device ID. And as we can see, the unique ID is already configured. After selecting all of my configuration settings, I will hit Pair, and the wireless device will become included in the Port Configuration tab. If I have integrated the IODD file from my iLink device, I will see Parse Process Data and can read-write parsed acyclic data. IODD files can be added straight from the IODD Finder or added manually via the IODD Uploader tab. Underneath the IODD Uploader tab is the Alerts and Events tab, which shows the errors and events for all iLink devices in my configuration. The errors and events are device specific, and as you can see, I can use these events to track errors such as short circuits or heavy current draws. Thank you for watching. If you have any questions, please see our other videos or open a ticket by going to cortigo.com and clicking on Support. Thank you.